Hello and welcome back to College Algebra, MAT 150. In this lecture, we're just going to cover some examples of polynomial division. So in the last lecture, we talked about how to divide. We talked about the very basics. Let's go through some more in-depth examples. So the first one we're going to look at is 3x cubed minus 5x squared plus 10x plus 1, and we're going to divide it by 3x plus 1. So we start. This is our dividend, or what we're dividing into. 3x cubed minus 5x squared plus 10x plus 1. And we're dividing by 3x plus 1. All right. Now, what do we do to start? We divide the leading term by the leading term. So 3x cubed divided by 3x. 3x cubed divided by 3x, the 3's cancel. X cubed divided by x is x squared. So we have x squared. And then so we divide, we multiply. X squared times 3x is 3x cubed. X squared times 1 is x squared. And then we subtract. So divide, multiply, subtract. Cancel. Again, that's how we know we did it correctly. Minus 5x squared minus x squared is negative 6x squared. And then we just bring the other terms down. So plus 10x plus 1. So we divided, multiplied, subtracted, brought down. Then we start again. So the leading term now is negative 6x squared. We're going to divide that by 3x. Negative 6x squared divided by 3x is negative 2x. So we have minus 2x as the next term of our quotient. And then we divided, we now multiply. Negative 2x times negative 3x is negative 6x squared. Negative 2x times 1 is negative 2x. And then so we've divided, multiplied. We're now going to subtract. Remember, subtracting means we're changing the sign. So minus 6x squared becomes plus. Minus 2x becomes plus. And we get negative 6x squared plus 6x squared. Again, that's how we know we did it correctly. These two terms naturally cancel when added to each other. 10x plus 2x is 12x. And now we bring down the last term, plus 1. Leading term is 12x compared to 3x. 12x and 3x, these two polynomials with the leading terms are the same degree, so we continue. So 12x divided by 3x, which equals 12 divided by 3 is 4, x divided by x cancels. So we have 4, we put plus 4 here. Then we divided, we multiply, so 4 times 3x is 12x, 4 times 1 is 4, and then we subtract. Minus 12x minus 4. 12x is canceled, but we have 1 minus 4 is negative 3. And this was our remainder. And what is the final answer? Well, what is 3x cubed minus 5x squared plus 10x plus 1 divided by 3x plus 1? It equals our quotient, x squared minus 2x plus 4, plus the remainder, which is negative 3, over 3x plus 1. Now, we don't have to necessarily write it like this, but just to kind of clarify, quotient plus remainder over divisor, yes, okay? When I say we don't have to write it like this, we could take the negative 3 and we could put x squared minus 2x plus 4 minus 3 over. So take the negative and put it out here and just put minus 3 over 3x plus 1. That perhaps looks nicer, but this would be sufficiently fine. This is correct. All right, so what about this next one? Well, this next one, which we unfortunately did not leave ourselves too terribly much room for, should be something similar, but notice that unlike the previous one, this is of degree 4. So we're going to be doing this a little bit longer. But we're dividing by x minus 2, so there's not as much entertainment with the coefficient in front of x. It's just 1, which is good, perhaps. So let's start. So 3x to the fourth plus x cubed minus 15x squared plus 6x minus 8. We want to divide by x minus 2. Well, we start our traditional way, leading term divided by leading term. So 3x to the 4 divided by x. This is the leading term here, that's the leading term there. And we get 3x cubed. So 3x cubed. And then we divide, multiply. So 3x cubed times x is 3x to the fourth. 3x cubed times negative 2 is negative 6x cubed. We change the sign, so we subtract. So minus, and this becomes plus. 3x cubed, 3x to the fourth cancel, so we're on the right path. X cubed plus 6x cubed is 7x cubed. We bring these down. So minus 15x squared plus 6x minus 8. And we wash, rinse, repeat. Leading term divided by leading term. 7x cubed divided by x is 7x squared. So plus 7x squared. And then we multiply. 7x squared times x is 7x cubed. 7x squared times negative 2 is negative 14x squared. And then we change the sign. So we subtract, which is, again, equivalent to changing the sign. These cancel, as we hope. Negative 15x squared plus 14x squared is negative x squared. Then we bring down the 6x, we bring down the 8. This is degree x squared, this is degree x, so it's still bigger, so we keep going. Leading term divided by leading term, negative x squared divided by x, which is negative x. And then this goes in our quotient. And then we multiply, divide, multiply. Negative x times x is negative x squared. Negative x times negative 2 is positive 2x. Then what do? We go through and we change the signs. And then combine. These cancel. 6x minus 2x is 4x. Then we bring down the negative 8. This is degree 1. We have degree 1, so we continue. Again, we continue until this degree of what we have left over is less than that, which means we go until we just have a constant in this particular case. So 4x divided by x equals 4. So leading term divided by leading term, and this is the part we can put here. And we continue by multiplying. 4 times x, 4 times negative 2 is negative 8. And then we go through and we subtract by changing the signs, both of those terms. And in this case, both of them cancel out. And what do we have? We have a remainder of 0. So, writing this all out, what is 3x, again, try to keep this separate, what is 3x to the fourth plus x cubed minus 15x squared plus 6x minus 8 all over x minus 2? Well, it equals our quotient, 3x cubed plus 7x squared minus x plus 4. And because the remainder is 0, what did we see previously? If it had a remainder of 0 plus the 0 over the divisor, we don't have to put it. Remainder of 0 means just the quotient. The dividend divided by the divisor equals just the quotient. And this is our answer. For the next lecture, keep the complexity of this whole example in mind, so we can talk about this using a simpler method called synthetic division. See you in the next lecture.